We've looked at where quantum is going, segmented that in about 10 categories, and we're going out to market, finding early or mid-stage companies and saying, let's bring you into a public entity and incubate you and go to market.
As the quantum computing industry continues to evolve, it's only natural that quantum incubators start appearing. How do investors like this choose what technologies to back in early stages? We look at the choices being made by one such investor, supporting graphene quantum dots, a quantum blockchain, and algorithms with wide use cases in this episode of the Post-Quantum World. I'm your host, Konstantinos Karagiannis. I lead quantum computing services at Protiviti, where we're helping companies prepare for the benefits and threats of this exploding field. I hope you'll join each episode as we explore the technology and business impacts of this post-quantum era. Our guest today is the CEO of Spectral Capital, Sean Brehm. Welcome to the show.
Nice to meet you. How are you doing?
Yeah, great. I'm fine and happy to have you on. It's been quite a while since we talked about anything in the realm of quantum investing. So it's, I figure it's about time to just revisit this topic with someone new coming on. Before we continue, I just want to quickly point out that we do have some legalese in the show notes for anyone who's interested in reading. Whenever we touch on the investment topic, I have to say that this is in no way investment advice. It's just an interesting, educational, informational kind of chat. So that's all we're doing.
100%. And the opinions expressed are mine and mine alone, and not that of Spectral Capital. So we knocked that out.
This is awesome. By the time you're done listening to this episode, dear listener, you're going to have a legal degree. So this is great. So we're all prepared. So on that note, tell us a little bit about Spectral Capital.
Yeah. So Spectral Capital is, when you think about it, it's kind of like it's a quantum as a service, but it's a very unique kind of quantum as a service. It offers incubation. So what we're doing is we've kind of looked at, where quantum is going, and we've kind of segmented that in about 10 categories. And we're going out to market, finding companies that are in early stage or mid-stage companies and saying, why don't you come on board? Let's bring you into a public, entity, and let's incubate you and let's go to market. And then what that means to the investor is, there's so many things that can go right, and there's so many things that can not go as well right in quantum right now. So you're trying to distribute the risk to the investor and give them an opportunity that if one goes, what a home run. If all 10 hit, well, that's even better. So that was kind of the mindset behind it. And we really wanted to kind of take a practical approach to it, which is kind of a crawl, walk, run strategy. We know what quantum is going to look like in 5 to 7 years. But getting there, Konstantinos, is not like right away on some of the elements. Like when you look at, qubits and super entanglement and all the concepts associated with quantum chips. But there are technologies that we can implement today in the area of quantum algorithms and quantum ledger databases that kind of act a bridge between what we see in classical computing systems and quantum systems. And that's where we felt we kind of really had a niche. A lot of people are talking about Star Trek quantum stuff. And what we're saying is, hey, let's crawl before we walk, before we run, and kind of build a bridge between the two. So you want to make sure that, today's systems can talk to tomorrow's.
So to be clear for the listener, you're working on helping companies get going. And it's not so much that you run around just investing in stocks or anything. It's the opposite side. Yeah. Just so people are clear, which exactly. Even more separates us from the idea that we're giving them investment advice, but yeah. Okay. Absolutely. So give us a sense of what types of companies you're pulling in, like what kinds of technologies and companies you're building in this like umbrella.
Yeah, so on the far right end of the spectrum, we're bringing on companies that are getting involved in quantum chips themselves. Like, What's the future? How do I move qubits really well? How do I take advantage of entanglement and superpositioning? But we're doing something kind of unique in that space. We're really focusing on people that are leveraging some interesting concepts like, green wave technologies, talking about technologies where you can grow bacteria and you can split the mitochondria and you can move things at the speed of light through bacteria. Graphene is a big piece of what we're doing. I think, telling your users, your listeners, graphene is going to be the commodity of the quantum era. So we're looking at technology. We're looking at graphene technologies as well, and that kind of puts us in the far right compute stack side of the house. What a future microchip might look like, and then you go all the way to the other side, which is why the thing I would challenge your readers is, if I were to ask them this question, your listeners, is why do we need quantum computing? I mean, don't we have right now? Isn't that good enough? And the answer is quantum computing is about more efficiently transforming data into information. And I know about 90% of your audience is like, I thought they were the same. They're not. I mean, data is just a lot like oil. It's like, dead dinosaurs, kind of lumpy, and it kind of has some value, but you got to refine it into information. So quantum computing is about refining data into information really, really efficiently, and doing things that are going to make the current AI look kind of primitive. And so on the other left-hand side of the spectrum is, well, how do we build data management systems that will work with today's systems and the quantum system? So those are my left and right brackets we're kind of living within.
Yeah, so I definitely want to double click a moment and dig in a little bit. Can you give me an example of what type of like chip manufacturing company you're most interested in right now, like you're working with?
Yeah. So when you look at chip manufacturing, you've got some people in the marketplace that are saying, hey, we're going to go one route in hardware. And then you've got other people in the market saying, no, I think we can do this at room temperature instead of having to use supercooling. So when we're looking at our quantum, we're leaning more towards the room temperature guys because we think there's a lot of efficacy around that. And I think that's going to really determine the compute capability of, like you're familiar today with moving bits and bytes, right? So you get a Pentium chip or an AMD chip, and it moves a 1 or a 0. What's crazy is when you get into the chips of quantum era, it can be a 1 or a 0 or a lot more. And wrap your head around that, right?
Yeah.
So what we're looking is we're betting on people that are saying we're going to focus on low energy, low room, standard room temperature type stuff because, our critical infrastructure around the world is kind of struggling already, with batteries coming on board and electrical vehicles. And you're starting to see a lot of these, energy companies going, wait, we can't handle anymore. So we don't want to provide. We're looking for companies that are going to add burden to the existing critical infrastructure out there. And so we're focusing on that. And then, as I said, on the left-hand side, we're looking for really innovative algorithms that are quantum algorithms that can help us get the data positioned so that when those machines that crunch them are ready, it's kind of a confluence. It's like seamlessly integrates.
Okay. And do you envision these companies that you invest in working together somehow through you, or they just are kind of off there on their own and you just kind of got them rolling?
No, that's a great question. What we really look at is can they work together? Because what you're looking at is, you remember when we were kids and we learned about the space race that happened, when we weren't even alive yet. We learned about the space race. There was a lot of really cool derivatives that came out of just racing to put someone on the moon, right? Whether it was Tang to all the other, aluminum foil, all the other cool stuff we got out of it. Well, that's kind of our approach here. We know this is a race to quantum computing. So it makes sense for us to make sure that there's some interconnectedness between the companies that we're acquiring so that they can complement each other. And then you're reducing your risk for the investor and you're also increasing your likelihood for success.
Is there like one modality then of like room temperature qubit that you're most interested in? Yeah,
it's a great question. When you look at, turning bacteria into polymers, companies like Dow have been working on that for a while. What's the most efficient way to do that, right? And then how do you introduce, technologies that are emerging like graphene technologies where you can augment that polymer with graphene and get to the point where you've got these highly resistant kind of compute stacks, even ones that would potentially bend. So, when we were kids and we watched Star Trek and they had, basically these devices that could do them. We're at the point right now where you can literally envision a motherboard bending any way you want it to and put it into any form factor. So those are the kinds of things on the far right side of the spectrum, we're looking at is, we got these companies that are really doing well in graphene. We've got these guys on the far left that are building algorithms. So every day is fun because you just meet these. I was on the phone with a guy who's internationally known in Israel, and he's doing quantum dots.
There are graphene quantum dots also, and graphene quantum computing, it has been explored. So you're saying that that's one of the modalities that you're most interested in right now?
Yeah, I think it's an exciting one. Yeah, the more I dive into it, I mean, what's cool about graphene is, okay, I want to build a data center. Okay, let's use graphene to make the concrete dry 50% faster and then actually conduct energy. And then we can reuse that graphene in the solar panel arrays because they can get more spectral. They can enhance the spectrums of light. And then let's use that same graphene to put it into, what will eventually be a future motherboard. So yeah, there's a great example right there.
And this has been looked at, like lots of researchers and things like ETH Zurich and others have been looking at using graphene as a material. So do you follow some kind of then investment strategy? Do you pick a technology like this and then say, okay, we're pretty much only going to focus on this?
I think that's a great question as well. I think what we do is we kind of use these 10 categories of graphene as kind of our bumper rails and of quantum computing. And we kind of operate within those 12s, like, what are we looking on energy? What are we looking on? Is there somebody really good at superpositioning? So we kind of use those as our guideline. But what's really exciting, like if you spend a day with us, Konstantinos, you discover you'll bump into somebody from some other part of the world, and they'll go, hey, we took this approach. And you're like, okay, that kind of falls outside the category we're looking at. So we're a little bit flexible right now. We try to live within that kind of those guardrails. But once in a while, we find companies that kind of are so innovative that you have to pause and look at them. But yeah, generally we try to stick within a guardrail and those modalities and then see which ones seem to perform better. Then you start looking at, okay, what's the time to market? Because when you start thinking about your classical approaches, let's take a look at total addressable market. Well, it's not like you can really calculate the calculated annual growth rate yet. So, you really kind of spend your day sometimes just scratching your head going, okay, how soon can I implement this? And how can it implement what's happening today? In other words, we call that a quantum bridge. How can I make sure that if we put money in this thing, will it kind of support existing cloud infrastructure? If so, can it kind of enhance it before we just, try to, create this, this new emerging tech? We really kind of the final piece in our approach is we're like, okay, is this applicable on how we can enhance the computing classical systems today? And that's really, I think, the common sense approach we take. And we have some amazing technology that have been presented to us, but we just can't conceive. We can conceive them in 5 to 10 years, but if they're not practicable with current classical systems, it's probably too much of a risk for us.
Shifting then back to that other side you described with the algorithms, you acquired a company called Quantomo. Quantomo, yeah. It sounds like Guantanamo, yeah. Quantomo, not to be confused with a bad place, yeah. Quantomo. And they develop quantum algorithms, right? So can you tell us about those algorithms? Because they have a very specific use case.
It's fast. So the inventor has just been an expert in the area of cooperative distributed inferencing, and which is a mouthful, and I'll explain it in a second. But essentially, what he's been able to do is say, look, what we want to be able to do is look at all this data from all these hybrid locations and these hybrid systems, and we want to be able to solve a fundamental problem with data. And this is really interesting, and when he first said it to me, it was pretty powerful. He said, Sean, the problem today that quantum will solve is there's so much data that we don't know what we don't know, and we don't know what questions to ask. And when you hear that for the first time, you're like, okay, generalization. But then when you dive into it, so what you discover with a quantum algorithm like analytic tomography, you've probably experienced tomography firsthand if you ever got an MRI. If you ever gone and got an MRI scan. So essentially the way that works is it's basically slicing your body up.
Yep.
And then what tomography is doing is trying to figure out, okay, what's the next slice going to look like? And if the next slice falls within some parameters, then you're good. If the next slice doesn't fall within parameters, danger, Will Robinson, this could be cancerous, it could be an anomaly, etc. So the idea behind tomography is, how do I take a look at the mean field of what's going to happen and be able to identify patterns and find out how to categorize those patterns? And that's going to be extremely important when you get into the quantum era, because when you get into superpositioning and you look at entanglement, you've got data all over the place. So you need to be able to kind of forecast what you think is going to happen so you can start defining kind of like your left and right limits so that you just don't start meandering and lose vectors. So it's a really, when you watch it, if you think old school, I don't know how long you've been in tech, but we used to use things called a priori searches, where you don't have to actually define what you're asking for. It's like a priori discovery.
And what are the practical use cases? Would it be more like a search kind of use case?
Yeah, you got it. Congratulations, you nailed it, right? Bam. It's not really, so it's really no longer a search. It's really, it is able to parse out the spatial, the temporal, the thematic and semantic context, and then say, Konstantinos, is this what you're interested in today? Think, and then have a conversation with you. And we've seen the early versions of it, and it's literally, I've connected it to my Gmail, and it's asking me questions that are like, including like, how's my wife doing today, kind of stuff.
I'm envisioning all these quantum as a service offerings, right?
Yeah.
Is this starting to tie into some kind of a quantum approach to an AI competitor in some space? Can you talk a little about that?
Well, so I'll kind of break that in half. So first of all, it's kind of tying into what we call a distributed quantum ledger database. So you can plug it into a distributed quantum ledger database, and we're getting amazing results already. And you can actually see it work. If you go to the Spectral website and go to the Vogon section, and you'll see a flip that says Web 5 and DQLDB. You can kind of flip back and forth and you click on a button. You can talk to the ledger database. So that's one area that's really compelling. The other area it's going to have is immense applications like supply chain discoveries. We've already done some things we can't talk about in the defense community with it. It's pretty crazy. It has huge things. I always hate the ones everybody uses, like, it's going to redefine drug discovery. I don't go down that route because that's the standard one with quantum computing. But what it's going to do for the average person is it's going to help you understand some things that you may not be aware of, and then help you, whether it's planning your calendar or whether it's telling you, how to manage your budget or how to manage your health better. It's really going to be a much more semantically aligned application where it's really going to learn you faster and then really serve you. For me, I'm a big fan, in this dystopian view of technology. I've always been, the technology should be here to serve mankind. So I always tend to lean towards, what it's going to do to the average person and help them out.
So what's the goal to get something like that onto a market? Would that be trying to sort of sell it to a major company like, I don't know, Google or something? Or
a great question.
What would be the approach?
Well, when you start, certainly I wouldn't be amiss if I haven't told you that we've had conversations with the big guys already through our chief scientist. Really in-depth conversations. I think the answer, instead of selling it, is kind of a hybrid approach. It's probably going to be more of a joint venture approach, which is, hey, let's go ahead and take what you're currently working on, take what we're working on, and kind of make it a combination of the both. Because certainly, a lot of people in quantum kind of look at classical compute systems and say, we're going to blow them away. Well, no, there's some really, really smart people in Microsoft and Google and IBM and AWS. So our attitude is, let's see where the intersections are between this company and where you're trying to go. What we see is quantum computing and AI kind of going along side by side for a while. And I'm going to say some things a lot of people might do on an uproad, but I think quantum computing is going to subsume AI, and it's going to be part of quantum computing. And the reason why is, when you understand about how you surface hard, soft, and absolute rules and use entropic models and vectoring for AI, I've been doing big data for years. now all of a sudden, when you're leveraging the power of superpositioning and qubits, you have the ability to look at so much disparate data at the same time that you're able to concept derive at the speed of light. I think you're going to see some really unique emergence of semantically aligned ontological models that work with quantum computing.
Interesting approach. I mean, we all think about how they're merging. Of course, the simplest version is that you just come up with some kind of quantum AI use case. But it's hard to say, will you be optimizing the way that AI systems are run? Will you be feeding certain prepared data sets because a quantum computer pre-processed it? It's hard to say what that'll turn into ultimately. I wanted to ask you something. Are you familiar with Sabine Hassenfelder? She's like a physicist that has a lot of controversial opinions about quantum computing in general. One of them recently,
I'm so lane focused right now. I haven't.
Oh, okay, yeah. One thing she said recently was that because quantum isn't quite here yet, basically that it's still evolving. That when companies go public, they do so through a SPAC, and then she was kind of being really, I guess, aggressive in stating that maybe these SPACs are just sort of like a pump and dump scheme.
Oh yeah, I can see that.
Like, do you have any opinions on that? Just personal opinions about what that kind of.
I think she's got a valid point, right?
You do.
And when we made our decision, we thought about that, right? We thought about, I think you want to look for a roadmap. Certainly, if I'm going to give you pie in the sky, we got this future quantum chip that'll be ready by 2030. Definitely pump and dump, right? But one of the things that we've done is we have a working distributed quantum ledger database today, right now. It works. It looks like it looks like a super hyper efficient version of a blockchain kind of merged with MongoDB, right? It works. And so the idea behind that is, again, I'm going to go back to what I said in the beginning is if you fundamentally don't understand that the purpose of quantum computing is the more efficient way to transform data into information at scale, then you probably shouldn't be in quantum computing, right? Because at the end of the day, the whole reason behind data is the new oil, right? So like oil, you got to refine it. So, oil refineries have petroleum engineers. Well, now data engineers are called data scientists, right? And AI engineers. So you want to refine that data into information, and then you want to make it sure that it gets to you in a spatially good context in a timely way. It's got a theme that's relevant and it's semantically aligned to yourself. That's the foundational purpose of quantum computing. If not, why are we even spending time on it, right? And the other advantage of quantum computing is you ought to be able to secure your data. I mean, everybody's talking about quantum computing, but a lot of people aren't saying one of the biggest reasons is, do you know what cybercrime is going to be by the year 2025? About $11 trillion.
Oh, okay. You meant in terms of amount. Okay.
Right? Yeah. So here we are going, well, we really don't need quantum. Oh, because cybersecurity is working really well for you right now, right? I mean, you've got so many companies going public in cybersecurity, but the slope on cybercrime still is like this. So what happens when you start implementing, cryptographic, quantum secure hashes around representing who you are? So I think, one thing I would look at is if you're going to look at a company that's going to space, or what are they doing from securing the data perspective first? Because that's the foundations. And then from that, how are they extending that secure data and making it usable and tangible in a way that has real business use cases to it?
For those who aren't actually trying to pull in companies or work with them on that level, do you think it's too soon to just be investing privately? Like if you were just giving opinion?
Yeah, I mean, here's what I would tell everybody. I'm a big fan of history. So, we had the Western Union in the 1800s, and everybody was so excited about Western Union. I could go down and give my little note, and I'm sitting in Boston, and I could send it to my great aunt in San Francisco, and it got there in minutes. And by the time the guy with a little nice hat came to your house, an hour later, I got a message, and everybody was happy about that. And all of a sudden, Alexander Graham came along, Alexander Graham Bell, and he built the phone, and he completely eclipsed, Western Union. And then we saw, 1994, we saw people on Good Morning America trying to figure out what the @ symbol is, right? And we saw how transformational the internet was. Well, we're at that moment. So what I would tell you is I'm not here advocating investing in Spectral Capital. I'm advocating you get involved in quantum because and figure out how to manage your risk in there, because it's going to have the similar impact that we continually see from Western Union, to the Alexander Graham Bell, to the internets, to today. I mean, it's going to foundationally change the world. In fact, so much so, I believe that nations that lead the way in quantum computing will dominate the global economy in the next 50 years.
To go with like an AI parallel, there were ways to make money without investing directly in AI. Like, for example, if you just so happen to be an NVIDIA investor, wow, you made out like gangbusters once, we started boiling oceans just to ask what the weather is. Well,
look at NVIDIA. They were building the CUDA architecture 10 years ago, and they took advantage of the gaming world, right? I mean, everybody wanted NVIDIA card for their gaming. So, yeah, there's going to be peripherals. So I think you nailed it. Look at the periphery around quantum computing as well.
Yeah. And like I said, of course, we can't give exact investment advice here. So I'm not going to ask you to dig into any companies or anything like that. But yeah, it might make sense to also consider, instead of the ones that are calling themselves quantum, there are things associated with that, right? Hey, maybe someone does the cryo facilities. Maybe someone does, whatever components are useful in there.
Yeah, there's some private companies right now that are doing really cool things with supercooling, with liquid supercooling. I mean, yeah, exactly. 100%. Look at the derivatives around there. Take time to learn what quantum is and what it isn't. But my biggest recommendation is get involved somehow. Put it in your portfolio in some way.
Great. So on that optimistic note, I want to thank you for coming on.
I enjoyed it. Thanks so much.
Now it's time for Coherence, the Quantum Executive Summary, where I take a moment to highlight some of the business impacts we discussed today, in case things got too nerdy at times. Let's recap. Spectral Capital isn't about picking stocks, but rather incubating early and mid-stage quantum technology companies. The goal? To distribute risk for investors while fostering innovation. It's a crawl, walk, run strategy to build a bridge between today's classical computing systems and tomorrow's quantum future. Spectral Capital is betting big on graphene as the commodity of the quantum era, spotlighting its potential in everything from quantum chips to flexible motherboards. Can graphene lead to room temperature QPUs? We'll see. On the other end, Spectral is working with firms like Quantimo, which develops quantum algorithms to refine vast data sets into actionable insights. Sean painted a vivid picture of how these algorithms, inspired by tomography, think MRI scans, could revolutionize data management from supply chains to personal health. Spectral Capital fosters interconnectedness among its portfolio companies with the idea this synergy reduces investor risk while boosting success odds. Sean feels quantum computing might eventually subsume AI by processing disparate data at lightning speed. This isn't about replacing today's tech giants like Google and Microsoft, though. Like most of us in the industry, Sean sees a future where quantum enhances rather than obliterates classical systems. Sean addressed skepticism about quantum startups going public via SPACs, and pointed to Spectral's working quantum ledger database as proof of real progress. He advises investors look beyond the quantum hype to peripheral technologies, like NVIDIA's big AI windfall, and urges everyone to get involved somehow. That does it for this episode. Thanks to Sean Brehm for joining to discuss Spectral Capital. And thank you for listening. If you enjoyed the show, please subscribe to Protiviti's The Post-Quantum World, and maybe leave a review to help others find us. Be sure to follow me on all socials at Constant Hacker. That's Constant with a K, Hacker. You'll find links there to what we're doing in quantum computing services at Protiviti. You can also DM me questions or suggestions for what you'd like to hear on the show. For more information on our quantum services, check out Protiviti.com or follow Protiviti Tech on X and LinkedIn. Until next time, be kind and stay quantum curious.